The prime method of inquiry in science is the experiment. The key features are control over variables, careful measurement, and establishing cause and effect relationships. An experiment is an investigation in which a hypothesis is scientifically tested. In an experiment, an independent variable, or the cause, is manipulated, and the dependent variable, or the effect, is measured. Any extraneous variables are controlled. An advantage is that experiments should be objective. The views and opinions of the researcher should not affect the results of a study. This is good as it makes the data more valid, and less bias. There are three types of experiment: the laboratory or controlled experiments, field experiments, and natural experiments. This type of experiment is conducted in a well-controlled environment, not necessarily a laboratory, and therefore accurate measurements are possible. The researcher decides where the experiment will take place, at what time, with which participants, in what circumstances, and using a standardized procedure. Participants are randomly allocated to each independent variable group. It is easier to replicate, i.e. copy, a laboratory experiment. This is because a standardized procedure is used. They allow for precise control of extraneous and independent variables. This allows a cause and effect relationship to be established. The artificiality of the setting may produce unnatural behavior that does not reflect real life, for example, low ecological validity. This means it would not be possible to generalize the findings to a real-life setting. Demand characteristics or experimenter effects may bias the results and become confounding variables. Field experiments are done in the everyday, for example, real-life environment of the participants. The experimenter still manipulates the independent variable, but in a real-life setting, so cannot really control extraneous variables. Behavior in a field experiment is more likely to reflect real life because of its natural setting, for example, higher ecological validity than a lab experiment. There is less likelihood of demand characteristics affecting the results, as participants may not know they are being studied. This occurs when the study is covert. There is less control over extraneous variables that might bias the results. This makes it difficult for another researcher to replicate the study in exactly the same way. Natural experiments are conducted in the everyday, for example in real-life environment of the participants, but here the experimenter has no control over the independent variable as it occurs naturally in real life. Behavior in a natural experiment is more likely to reflect real life because of its natural setting, for example, very high ecological validity. There is less likelihood of demand characteristics affecting the results, as participants may not know they are being studied. Can be used in situations in which it would be ethically unacceptable to manipulate the independent variable, for example, researching stress. They may be more expensive and time-consuming than lab experiments. There is no control over extraneous variables that might bias the results. This makes it difficult for another researcher to replicate the study in exactly the same way. We have got a hypothesis, which is the first step in doing an experiment. Before we can continue, we need to be aware of some aspects of research that can contaminate our results. In other words, what could get in the way of our results in this study being accurate? These aspects are called research biases, and there are basically three main biases we need to be concerned with. Selection bias occurs when differences between groups are present at the beginning of the experiment. The placebo effect involves the influencing of performance due to the subject's belief about the results. In other words, if I believe the new medication will help me feel better, I may feel better even if the new medication is only a sugar pill. This demonstrates the power of the mind to change a person's perceptions of reality. And lastly, the experimenter bias is when a person's beliefs can influence his or her perception, so can the belief of the experimenter. If I'm doing an experiment, and really believe my treatment works, or I really want the treatment to work because it will mean big bucks for me, I might behave in a manner that will influence the subject. Controlling for biases. After carefully reviewing our study and determining what might affect our results that are not part of the experiment, we need to control for these biases. To control for selection bias, most experiments use what's called random assignment, which means assigning the subjects to each group based on chance rather than human decision. To control for the placebo effect, subjects are often not informed of the purpose of the experiment. This is called a blind study, because the subjects are blind to the expected results. To control for experimenter biases, we can utilize a double-blind study, which means that both the experimenter and the subjects are blind to the purpose and anticipated results of the study. We have our hypothesis, and we know what our subject pool is. The next thing we have to do is standardize the experiment. Standardization refers to a specific set of instructions. The reason we want the experiment to be standardized is twofold. First, we want to make sure all subjects are given the same instructions, presented with the experiment in the same manner, and that all of the data is collected exactly the same for all subjects. Second, single experiments cannot typically stand on their own. To really show that our results are valid, experiments need to be replicated by other experimenters with different subjects. To do this, the experimenters need to know exactly what we did so they can replicate it.